Good evening, everyone. So, last class we have discussed chemical equilibrium, right? So, today we'll start with ionic equilibrium. So, before getting into ionic equilibrium, what are all the subtopics we have discussed in chemical equilibrium? What are all the things we have discussed in chemical equilibrium? We have discussed what is equilibrium and equilibrium constant in terms of concentration and in terms of partial pressure, and relationship between Kp and Kc, yeah, and reaction coefficient. And by comparing the values of reaction coefficient with the equilibrium constant, we can predict the direction of the reaction. And finally, we have discussed Le Chatelier's principle, right? And also, okay, Muthulakshmi, okay, right. So we have discussed Le Chatelier's principle, and finally we have discussed few numerical based on that. So today we'll be starting with ionic equilibrium. Muthulakshmi?
Yes, ma'am. Yes, ma'am.
Okay, you're from?
I'm from Tamil Nadu in Chennai.
Okay, Kana. You're in 11th standard or 12th standard?
12th standard complete பண்ணிட்டேன் ma'am.
Okay, repeaterங்களா?
Yes, ma'am.
Okay, right, Kana, right. So we'll start with ionic equilibrium. So basically, equilibrium or this ionic equilibrium topic is from your 11th standard, okay? So I'm going to write 3 equations and I want you guys to tell me the difference between all the 3 reactions, okay? Okay, I've written 3 equilibrium reactions and I want you to tell me what is the difference between all the 3 reactions. Basically, what is equilibrium reaction? In a chemical reaction, both the rate of forward and backward reaction will be same, right? So Rf is equal to Rb. Okay, I've written 3 equilibrium reactions and I want you to tell me the difference between all the 3. In first reaction, A is my reactant, which is in solid state. It is getting converted into A again, but the physical state is liquid. Here, the equilibrium is established between A, which is in solid state, with A, which is in liquid state. So this kind of equilibrium is called physical equilibrium. This kind of reaction is called physical equilibrium. Equilibrium is established between 2 different physical states. And here, A is an equilibrium with B. A is another chemical compound and B is another chemical compound. So the equilibrium is established between 2 different chemical components. So this is called chemical equilibrium. Here, AB is a chemical compound and it is an equilibrium with A plus and B minus. These two are the constituent ion of this compound, right? So here this is called ionic equilibrium. So a chemical compound is an equilibrium with its constituent ion. So this is called ionic equilibrium. Okay. So we have done with chemical equilibrium already. So now we'll start with ionic equilibrium. Fine. So before getting into ionic equilibrium, we have to know few concepts like what is electrolyte, different types of electrolyte, what is acid, base, their definitions, and how to calculate pH of the solution. See, calculating pH of the solution is very, very important as far as ionic equilibrium is concerned. So we'll start with electrolyte. So what is electrolyte? What is electrolyte? This term you have studied in your electrochemistry also. If you guys are from 12th standard, this term is not new to you. Electrolyte. Okay. I'm going to take a chemical compound, for example, NaCl. And I'm going to dissolve this NaCl in water. So this NaCl will get dissociated into Na plus and Cl minus, right? So if you take a chemical compound and if you dissolve that chemical compound into any aqueous medium, that will get dissociated into cation and anion. Then this chemical compound is called an electrolyte. Okay. For example, HCl. I'm going to dissolve HCl in water. How it will get dissociated? It will get dissociated into H plus and Cl minus. So HCl is an electrolyte. Okay. How about NaOH? NaOH is sodium hydroxide. If you dissolve sodium hydroxide, it will get dissociated into Na plus and OH minus. So sodium hydroxide is also an electrolyte. Okay. And now what is this? CH3COOH. What is this? CH3COOH. What compound is that?
Acetic acid.
Very good, acetic acid, or it is also called as ethanoic acid. So if you dissolve acetic acid in water, it will get dissociated into CH3COO minus and H plus. So acetic acid is also an electrolyte, but it is little acetic acid is little different from rest of the electrolytes. I'll tell you the difference also. Okay, what compound is this? NH4OH. What compound is this? NH4OH.
Ammonium hydroxide, ma'am.
Yes, ammonium hydroxide. So ammonium hydroxide will get dissociated into NH4OH, OH minus. See, here undissociated compound and its constituent ions were in equilibrium. Here also undissociated compound is in equilibrium with its constituent ions, right? See, all the five categories, all the five categories electrolyte, but there is a difference between first three and last two. What is the difference between first three compound and last two compounds? See, as far as sodium chloride is concerned, if you dissolve 100 molecule of sodium chloride, all the 100 molecule will get dissociated into Na plus and Cl minus ion. So how many Na plus and how many Cl minus will be obtaining?
100, ma'am.
100.
100 each. So here 100 molecule of NaCl was completely dissociated into Na plus and Cl minus. But as far as acetic acid is concerned, if you dissolve or if you add 100 molecule of acetic acid, only a few molecules of acetic acid will get dissociated into acetate anion and H plus ion. For example, if 10 molecule was dissociated, then you'll end up with 10 acetate anion and 10 H plus ions. And we'll be having 90 undissociated acetic acid. So here, this is only partial dissociation, but here it is complete dissociation. So this kind of electrolyte, these kind of electrolytes are called strong electrolyte. And these two types are called weak electrolyte. If a chemical compound dissociates completely to give its constituent ion, then that kind of compound is called strong electrolyte. If a chemical compound dissociates partially to give its constituent ion, then that is called weak electrolyte. So we have two types of electrolytes. Okay. So we have a parameter which denotes whether that is a strong electrolyte or weak electrolyte. That is nothing but alpha. What is alpha? Alpha is nothing but degree of
Degree of dissociation.
using the value of alpha, we can understand whether the electrolyte is strong electrolyte or weak electrolyte or weakest electrolyte. So there is a formula to calculate alpha. I'll tell you the formula. Alpha is equal to, please write it in the numerator, number of moles of or molecules of electrolyte, number of moles or molecules of electrolyte dissociated, number of moles or molecules of electrolyte dissociated divided by total number of moles or molecules of electrolyte added in the solution. What is in the numerator? Number of moles or molecules of electrolyte dissociated divided by number of moles of,
Total.
yes, total number of moles of electrolyte dissociated divided by total number of moles or molecules of electrolyte added in the solution. That's it. So now we'll apply alpha for strong and weak electrolytes here. As far as sodium chloride is concerned, I've taken 100 molecules of electrolyte. So total number of molecules of electrolyte taken was 100. And in which how many molecules of electrolyte was dissociated? How many molecules was dissociated? I've taken 100 molecules of NaCl, and in that 100 molecule, all the 100 molecule was ionized, right? So
Okay.
numerator is 100 and denominator is also 100.
100.
100 by 100 is equal to 1.
1.
So what we can infer is, as far as strong electrolytes are concerned, always alpha value will be equal to 1. If we want to express it in percentage, then multiply it with 100. So as far as strong electrolytes are concerned, degree of dissociation is 1 or it is 100% dissociated. Okay. Now we'll apply for acetic acid. Alpha is equal to total molecules of acetic acid taken was 100, in which how many acetic acid was dissociated? In which how many molecule of acetic acid was dissociated?
10.
10. Very good. So 10 by 100, which is 0.1. So in this example, for acetic acid, I've given you the hypothetical molecule. So using this hypothetical values, what we got is alpha is equal to 0.1 for this acetic acid. So what we can infer is, as far as weak electrolytes are concerned, degree of dissociation will be always less than 1. Okay. For strong electrolyte, alpha will be equal to 1, and for weak electrolyte, alpha will be less than 1. So here alpha is equal to 0.1, right? So please express it in percentage. What is the percentage ionization of acetic acid? You have to multiply it with 100. So
10.
very good. So 10%
10%.
dissociation. That's it. Okay. So I'm going to give you 3 values, and based on the values, tell me whether it is weak electrolyte, strong electrolyte, or weakest electrolyte. Alpha is equal to 0.2, alpha is equal to 1, alpha is equal to 0.0003. Among these 3 compounds, please tell me which is strong electrolyte, which is weak electrolyte, which is weakest electrolyte.
B is the strongest, ma'am.
Yes.
Followed by A and C, ma'am.
So this is weak and this is weakest. That's it. Okay, fine. So we have understood what is electrolyte, different types of electrolyte, and also degree of dissociation. Super. Now we'll understand what is acid and what is base, because throughout this chapter we'll be discussing lot of acids and bases. So we have to know what is acid and what is base. Okay. We have three definitions for acid and base. You have studied in your smaller classes. See? Okay, basically, what is acid, Kana? According to you, what is acid? You can come up with any definition or any properties related to acid. Anything is fine.
Ma'am, it accepts electron pair, ma'am.
Very good. Very good. Yes. Something which accepts electron pair is called acid. Fine. Okay, what else?
If it donates a proton, ma'am.
Okay. Something which donates proton. That is also an acid, right? What else? You guys know, but you're not telling me. Okay, how about base? Sendami Chelvan told me two definitions for acid. One is electron pair acceptor and proton donor. Okay, how about base? Okay, actually, we have three famous definitions for acid and base. So, first definition is Arrhenius definition. According to this concept, if you dissolve any compound in water and if that compound releases H plus ion, then that is acid. Okay. If any compound releases H plus ion in water or in aqueous medium, then that is acid. If you dissolve any compound in water, if that releases OH minus ion, then that is base. That's it. For example, guys, can you hear me now?
Yes, ma'am.
Yes. Sorry, Kana. Sorry. I'll reshare my screen. Is my screen visible? Is my screen?
Yes, ma'am.
Okay, right. So I'm going to take HCl and I'm going to dissolve this HCl in water. So this HCl will get dissociated into H plus and Cl minus ion. So this compound is releasing H plus ion. So this is called an acid. Similarly, if you dissolve sodium hydroxide in water, it will get dissociated into Na plus and OH minus ion. So, if a compound releases OH minus ion in water, then that is base. So, sodium hydroxide is a base. That's it. So, Arrhenius, according to Arrhenius definition, if a compound releases H plus ion in water, then that is acid. If a compound releases OH minus ion in water, then that is base. So basically, Arrhenius definition is based on aqueous medium, and this definition is not applicable for any of the solvent. Okay, it is applicable only for aqueous medium. Basically, solvent is water. Second definition is Bronsted and Lowry, and this definition is applicable for both aqueous and non-aqueous medium. If you dissolve any compound in water or in any other solvent, if that compound releases H plus ion, then that is acid. If that compound accepts H plus ion from the solvent, then that is base. H plus is nothing but proton. Why H plus is called as proton? Why H plus is called as proton?
Ma'am, hydrogen atom have only one proton and electron, ma'am.
Very
We
good,
remove the
yes.
electron,
Mm. If we
it will
remove
only.
the electron, it will have only proton. Super. See, as far as hydrogen atom is concerned, atomic number is 1, mass number is 1. So number of proton is 1, number of electron is 1, and there is no neutron in hydrogen, right? So as far as hydrogen is concerned, we have 1 proton and 1 electron. How about H plus? We removed 1 electron there, which means number of proton is 1, but there is no electron also. So H plus ion contains only 1 proton, then that is why it is called as proton. Okay. And if you dissolve any compound in aqueous or in non-aqueous medium, if that compound uh, releases proton, then that is called acid. So proton donor is called acid. If that compound accepts H plus from the solvent, then that is base. So proton acceptor is base. Third definition is based on electron pair, which is called Lewis concept. If a compound accepts electron pair, then that is called acid. Electron acceptors are called acid, specifically called as Lewis acid. If a compound donates its electron, then that is Lewis base. Electron donor is Lewis base. Can you please tell me which are all the species which can act as Lewis acid? Which can act as Lewis acid? That chemical species have to accept electron, right? Which species will accept electron? Basically, that species has to be electron deficient, right? Only electron deficient species can accept electron. So basically, how you'll represent electron deficient species? Yes, positively charged ions. As Sendamit Shelvin said, positively charged ion. He told me cations. Basically, cations are positively charged. So any positively charged species or electron pair acceptor. And what else? There is a classic example. See, what is this, Kanna? Boron trifluoride. This is a neutral molecule, right? There is no positive or negative charge on this molecule. The structure of boron trifluoride is boron is connected with 3 fluorine atoms. So around this boron, we have 3 chemical bonds, and each chemical bond we have 2 electrons. So totally how many electrons are there around this boron? How many electrons are present around this boron? 6 electrons, right? What is octet rule? In a molecule, central atom should have 8 electrons. Then only that compound will be stable, right? So according to octet rule, is BF3 stable? Is BF3 stable?
No, miss.
No. because this boron contain only 6 electrons. So boron is in need of 2 more electron. Though BF3 seems to be a neutral molecule, this boron is in need of electron. So BF3 is also called as electron pair acceptor. So basically BF3, it will come under incomplete octet compound. So compound with incomplete octet will also act as a Lewis acid. Incomplete octet. How about electron donors, Kana? How electron donors will be? How electron donors will be? They're electron rich species, right? So how you'll represent any electron rich species? Usually they are negatively charged ions or any molecule with lone pair of electron. They'll come under loose base category. Okay. So these are the three famous definitions for acid and base. Okay. Fine. We can expect a question from Bronsted and Lorry concept. So we're going to discuss one particular problem, or we're going to discuss one particular concept, followed by we'll be discussing a problem related to that. And now listen here. I have HCl. Okay, and I'm going to dissolve HCl in water. This is the formula of water, right? So oxygen got 2 pairs of electron. Now what HCl will do? It will get dissociated into H plus and Cl minus. What H plus will do? It will get attracted towards oxygen because oxygen got 2 lone pair of electrons. So in water molecule, oxygen is electron rich. So oxygen will use its one of its pair of electron to accept H plus. So this H plus ion will combine with water. See, this is the structure of water, right? Oxygen with 2 pairs of electron. Now H plus gonna get connected with oxygen using this lone pair of electron. So the structure would be oxygen and one more hydrogen, it will get attached to oxygen. So oxygen will have only 1 pair of electron. Now oxygen lost its pair of electron by gaining H plus ion. So oxygen will have a positive charge. So this is called as hydronium ion. Hydronium ion. So water molecule will accept a H plus from HCl and it will get converted into H3O plus. And what is the remaining species? What is left out now? What is left out?
Cl minus.
Very good, Cl minus. That's it. So as far as forward reaction is concerned, which is acting as an acid and which is acting as a base based on Bronsted and Lorry concept? As far as forward reaction is concerned, which is losing H plus and which is accepting H plus? Yes. So HCl is losing its H plus, right? So HCl is called as acid. And water is accepting H plus from HCl. So it is called as base. So this is proton donor and this is proton acceptor. Now we'll check the backward reaction. As far as backward reaction is concerned, which is acting as acid and which is acting as base? Now the reacting species are H3O plus and Cl minus, right? Now H3O plus is losing its hydrogen and that hydrogen is combining with Cl minus. So Cl minus is accepting H plus. So Cl minus is considered to be your base and H3O plus is called as an acid, right? So this is called as conjugate acid and this is called as conjugate base. Kana? So this HCl, this acid and this conjugate base, this is a pair. Similarly, H2O and H3O plus, base and conjugate acid, this is one pair. The question what we can expect is they'll give you any chemical compound and they may ask you to write the conjugate base of that compound or conjugate acid of that compound, and it is very easy to write. I'll give you the shortcut now. Listen here. H2O is my compound. Okay. And they may ask you to write the conjugate acid of this compound or conjugate base of this compound. Okay. What is acid? Acid is something which donates its H plus. Basically, acid should have H plus ions. So whenever they're asking for conjugate acid, please remember that you have to add one H plus ion. You have to add one H plus ion. So here H2O, to this H2O you have to add one hydrogen, which means it will get converted into H3O, and it is a neutral molecule to which you have to add one positive charge. So H3O plus is the conjugate acid of H2O. Similarly, when you're writing for conjugate base, you have to subtract one hydrogen and you have to reduce one positive charge from the compound. So how we can do that? The formula is H2O. From that, we have to remove one hydrogen. So it will get converted into OH, and it is a neutral molecule. And from neutral molecule, you have to reduce one positive charge. So it will get converted into -1. So OH minus is the conjugate base of H2O. Am I clear? Any doubt? Shall we do for one more chemical compound? Okay. I want you to try it for ammonia. What is the conjugate acid of NH3 and what is the conjugate base of NH3? What is the conjugate acid of NH3 and conjugate base of NH3?
Ammonium ion and ammonium hydroxide, ma'am.
Okay, ammonium ion. So you have to add one H plus ion. So NH4, and you have to add one positive charge. So it is a neutral molecule. So to which I'm going to add one positive charge. That's it. As far as conjugate base is concerned, you have to remove one hydrogen. So it will get converted into NH2. And this is a neutral molecule from which you have to reduce one positive charge. So it will have one negative charge. So NH2 minus is the conjugate base of ammonia. See, Kana, all the species will not have both conjugate acid and base. Some species will have only conjugate acid, some species will have only conjugate base. It depends. For example, HF. See, this HF will not have a conjugate acid, but we can write a conjugate base for that, which is F minus. And similarly, I want you guys to write it for SO4, HSO4 minus. Write the conjugate acid and conjugate base.
H2SO4, ma'am.
Very good.
SO4 2 minus.
Yes. See, HSO4 minus is the species. So you have to add one hydrogen. So it will get converted into H2SO4, and it is a negatively charged species to which you have to add one positive charge. So -1 plus 1, it will get converted into 0. So there is no charge on H2SO4. Similarly, you have to write the conjugate base. So you have to remove one hydrogen. So already we have only one hydrogen from which we have to remove it. So SO4 minus, and you have to remove one more positive charge. So one more negative charge will get added. So SO4 2 minus is the conjugate base of HSO4 minus. That's it. Can you do it for HS -1?
H2, yes, ma'am.
H2, yes. And conjugate base,
H2 minus, ma'am.
that's it. Any doubt? Any doubt? Okay. Shall we move on to next concept? So we are done with electrolyte. We are done with types of electrolyte. We are done with degree of dissociation. We have discussed three definitions of acid and base. That's it. Now we'll move on to very important concept called pH. So initially we'll see what is pH, how to calculate pH, and also we'll be discussing different pattern of problem because as far as ionic equilibrium is concerned, we can expect lot of pH related questions. Okay, we may expect a pH related question in buffer solution, hydrolysis of salt, common ion effect, or general any weak acid. They'll give you any weak acid or any weak base, and they may ask us to calculate the pH of the solution or pH of the solution. So we have to know all the patterns. So first we'll start with just pH. So now what is pH basically? You have studied in your 10th standard at least.
Power of hydrogen, ma'am.
Yes, power of hydrogen. What this pH represents? From the value of pH, what we can infer, what we can understand.
We can understand whether the thing is acid, base, or neutral, ma'am.
Yes. So from the value of pH, we can understand whether the solution is acidic or basic or neutral. And also from the value of pH, we can calculate the H plus ion inside the solution. We can calculate the concentration of H plus ion in a solution. Right. Do you know what is the formula to calculate pH? What is the formula to calculate pH? pH is equal to minus log of H plus ion concentration. So instead of this small p, you can have it as minus log. That's it. So here H plus. That's it. Similarly, POH. POH represents the concentration of OH minus ion inside the solution. So what will be the formula to calculate POH? It's very similar to your pH formula. Minus log of, instead of P, I've written minus log. Instead of H, I'm just writing the hydrogen same, right? So here also minus log of OH minus ion. That's it. So the value of pH will give you the concentration of OH minus ion in a solution. That's it. Is there any relationship between pH and pOH? Is it possible for us to calculate the pOH value from pH? Yes, it is possible. Yes, Muthulakshmi, very good. And what is the formula to do that? pH plus pOH is equal to 14. Anyways, we're going to derive all these relationships. Okay, we're going to derive this relationship, so don't worry. But in your, in your classes and all, from your 10th standard at least, you have studied these formulas. Right. So to calculate the pH, we have to be very thorough with log values, Kana. So first we'll clear this logarithm part. Okay. I'll give you few formulas and few values to memorize. Please memorize that. Based on these values, we can always calculate log, anti-log, everything. You need not use any logarithm table, or you need not use any calculator. So the basic formulas are, if it is ln, then please convert that into log. Have to convert log to ln, ln to log. Ln is equal to 2.303 log. That's it.
0.3.
Log A into B. What is the formula or expression for log A into B? Log A plus log B. What is log A by B?
Log A
Log
minus
B.
log B.
Very good. Log A minus log B. Super. What is log A power B? We have to
B log
bring
A.
this power. Very good, Kana. B log A. That's it. We need only these three formulas. And what is the value of log 10?
1, ma'am.
Very good. What is the value for log 100?
2.
Yes. How this log 100 can be written log
Log
10
10 power
square?
2.
Yes. So 10 power 2. So it is like log A power B. So I can have it as 2 into log 10. So log 10 value is 1. So 2 into 1 is 2. Very good. So log 1000 is 3.
3.
Right. How about log 0.1? 0.1 is nothing but log 1 by 10. Right. So what is this 1 by 10? I can bring this
Minus
10 to the numerator. Log 10 power minus 1. So which is minus 1 log 10. So minus 1 into 1 is minus 1. That's it. Log 0.01 value is similar to the previous case.
-2.
Very good. It is minus 2. 0.001 is minus 3. That's it. Now a few values. What is the value of log 2? 0.3010. Log 3. 0.4771. Log 5. 0.6989. Log 7. 0.8450. By using only these values, we can calculate all the log values and anti-log values. Okay. What is the value of log 1 then?
0, ma'am.
0,
That's
ma'am.
it. Very good. Very good. Now, I'll give you a problem. Can you please calculate log 45? So first split this 45. How we can split 45? We can have it as
Log
9 into 5. Yes, Kana? So 9 into 5 is 45, right? So it is like log A into B. I can write it as log A plus log B. We don't know the value of log 9, but how we can write this log 9 as log 3 square? So log 3 square can be written as 2 into log 3 plus log 5. That's it. So 2 into, you know the value of log 3, which is 0.4771, and value of log 5 is 0.6989. So by simplifying these values, you'll get the value of log 45. Am I clear? Any doubt? Fine. Right, Kana. So if it is a whole number, no issues, we'll do it. But as far as ionic equilibrium is concerned, definitely we will not get any simple values like this. It will be quite complicated. Anyways, we'll start with a problem. In that problem, I'll teach you how to find the log values if the number is getting complicated. So, 1 minute. Yes. Here's the question. The concentration of hydrogen ion in a sample of soft drink is 3.8 into 10 power minus 3 molarity. And what is its pH? So the question is very direct. They've given you the hydrogen ion concentration itself and they're asking us to calculate its pH. So what is hydrogen ion concentration? Basically H plus ion concentration, which is given as 3.8 into 10 power minus 3. And we have to calculate pH. And what is the formula? pH is equal to minus log of H plus ion concentration. So minus log of what is H plus ion concentration? It is given as 3.8 into 10 power minus 3. Right. See, keep this minus sign as such. Have this log 3.8 into 10 power minus 3. It is like log A into B. So we can write it as log A plus log B. Log 3.8. Now, how we can write log 10 power minus 3 as? It is like log A power B, right? So we can bring this power term.
Minus log
Right, very good, very good. Minus 3 log 10. What is the value of log 10?
1, ma'am.
1. So I'm going to multiply this negative sign. So minus log 3.8 minus into minus plus 3. Log 10 value is 1. That's it. So what is pH? 3 minus log 3.8. So here itself we can screen the answer, right? Definitely pH will be less than 3. So what will be the answer?
2.42, ma'am.
Very good. 2.42. Also, we can calculate the pH exactly also, no issues. See, what is the value of log 2? It is 0.3010. Value of log 3 is 0.4771. And log 5 is 0.6989. Kana, what is 3 point? I mean, where this 3.8 will come? Somewhere between log 3 and log 5. In fact, we can calculate the value of log 4 also. Could you please tell me the value of log 4? We need not memorize, right? We can always calculate. So what is the value of log 4? What is the value of log 4?
0.6020.
Very good. So 0.6020. So log 3 value 0.4771. Log 4 value 0.6020. So where 3.8 will be somewhere between these two values. So approximately, could you please tell me the value of log 3.8? Value between 0.4771 and 0.6020. Any approximate value will do. 3.8 means it is towards 4, right? So could you please tell me the appropriate value for log 3.8? Okay, Muthulakshmi's value 0.5809. Okay. 0.5809. Now can you please calculate a pH? If the value of log 3.8 is 0.5809, then what is its pH? 3 minus 0.5809. What is the answer, Kanna?
2.95 something, ma'am.
Kanna, is it 2.9?
Yes, ma'am.
Can you please do it again? You told me the exact value is
Sorry,
not
sorry.
3.8.
It's 2.5, 2.5, not 9, ma'am. 2.5.
Okay. So approximately 2.5.
5, ma'am.
Okay. So obviously answer is option C. Right? Any doubt? Sensible children? Okay. Now here the problem is they have given you the H plus ion concentration and from which we have calculated pH, right? Now one more problem. Here the problem is quite opposite. The pH of a sample of vinegar is given as 3.76 and they're asking us to calculate the concentration of hydrogen ion in it. So the value of pH is 3.76 and from the value of pH we have to calculate H plus ion concentration. Okay, shall we do it together? Kana, listen here. What is the formula, Kana? So the given value is 3.76. What is the formula for pH? Minus log of H plus ion. So minus log of H plus ion is equal to 3.76. So we have to calculate H plus ion, right? So we have to have H plus ion to the left and we have to bring all the parameters to the right. So first of all, multiply this equation throughout with negative sign. So what will be the next step? Log of H plus ion is equal to minus 3.76. So what is H plus ion? We have two ways here. If you bring log to the right side, it will get converted into 10 power. You have to write this minus 3.76 in the power. Minus 3.76. But we have no options like that. Right? So it will not work out now. But this is also right, Kana. If you do it in calculator, you'll get the answer. But you cannot do it manually, right? So we have another option to do this. See, listen here. H plus ion is equal to, if you bring log to the right side, it will get converted into anti-log. So anti-log of minus 3.76. So if you calculate the anti-log value of this, you'll get the answer. So how we can do that? Listen here. H plus ion concentration is equal to anti-log of minus 3.76. First step is split this value. So split the number like this, Kana. Minus 3 minus 0.76. So what is minus 3 minus 0.76? Obviously it is minus 3.76, right? And make sure we have positive sign in front of this decimal value, but here we have negative sign, so we have to make it positive. How to do that? Minus 3 minus 0.76, you have to add plus 1 and you have to add minus 1. So plus 1 and minus 1. See, combine these two values, plus 1 and minus 0.76, and combine minus 3 and minus 1. So anti-log of minus 3 minus 1 is minus 4. And please simplify this, Kanna. Minus 0.76 plus 0. Plus 1. What is the answer?
0.24, ma'am.
Yes, plus 0.24. Now we got positive sign in front of this decimal value. That's it. Now the final step is you have to write this minus 4 in terms of log. How we can do that? Log 10 power minus 4 is nothing but minus 4. Right? Am I right? Minus 4 can be written as log 10 power minus 4 because log 10 power minus 4 is nothing but minus 4, right? Similarly, we have to write the 0.24 in terms of log. Have to do that. That is also very easy. Listen, if the value is 0.3010, if I have to write the 0.3010 in terms of log, I'll write it as log 2, right? Similarly, if the value is 0.4771, I can write it as log 3. Here, the value is 0.24. Where 0.24 will come? Somewhere here. And we know log 1 is 0. Right, Kana? So, if the value is 0.24, then what will be its log? Somewhere between 1 and 2. Could you please tell me between 1 and 2 what will be its log? You getting my point? You have to write 0.24 in terms of log. You getting my point? Okay. Can you please tell me any log between log 1 and log 2? Because we have to write 0.24 in terms of log. If the value was 0.3010, then I can write it as log 2. If the value is 0.4771, I can write it as log 3. But here the value is 0.24. So log must be between log 1 to log 2. So Muthulakshmi's answer is 1.7. Okay, right. So if it is 1.7, this is how I have to write, right? So anti-log of this is log A plus log B. I can write it as log A into B or B into A. Anything is right. Log and anti-log will get cancelled. So what is the H plus ion concentration? 1.7 into 10 power minus 4. So what is the answer? What is the answer? First option. You guys getting my point? Any doubt? Any doubt? Shall we do one more problem related to this anti-log stuff? One more problem. And our calculation part is easy. But the thing is you have to practice. I'll give you one more problem. Here's the question. Calculate the hydrogen ion concentration in the following biological fluids whose pH are given below. For which we can calculate H plus ion concentration now. Anything is fine. For which one you guys are doing? Shall we do it for human blood? pH of human blood is given as 7.38. Can you please calculate the hydrogen ion concentration? So the question is, you have to calculate the hydrogen ion concentration for human blood. pH is given as 7.38. Please problem and do it.
ஒரு டென்ஷன் இருக்கும்ல 3.6 into 10 power minus 8. My god.
Okay. Come again, Kanna.
3.6 into 10 power minus 8.
Very good. The original answer is 4 into 10 power minus 8. So your answer is right. That's
Okay,
it.
ma'am.
Very good. Very good, Lakshmi. So please do rest of the problem as activity, and I'll give you one more problem for practice. pH of milk, black coffee, tomato juice, lemon juice, egg white are given, and all here also we have to calculate hydrogen ion concentration. Okay, so take these two problems as activity. Please practice. Okay, calculating H plus ion concentration or taking anti-log is very simple. The key is practice. Okay, fine. So here we saw two pattern of problem where H plus ion concentration was given, from which we have calculated pH, and second category is pH was given, and from that we have calculated H plus ion concentration. Third pattern is they'll not give you H plus ion concentration directly. They'll give you the concentration of any acid. So from that concentration of acid, you have to calculate H plus ion concentration, from which you have to calculate pH. For example, okay, I'll give you a problem itself. Here is the question. Assuming complete dissociation, calculate the pH of the following solution. Here, HCl is an acid for which the concentration is given. Kanna, acid's concentration is not always equal to the H plus ion concentration. As far as HCl is concerned, no issue, because as far as hydrochloric acid is concerned, after complete dissociation, it will get converted into H plus and Cl minus ion, right? So upon complete dissociation, all the HCl will get dissociated to H plus and Cl minus ion. If you take 1000 molecules of HCl, all the molecules will get dissociated into H plus and Cl minus, where we'll be having 1000 H plus ion and 1000 Cl minus ion. Okay, so here the concentration is given as 0.003 molarity of HCl, and upon complete dissociation, what will be the concentration of H plus ion? It will be 0.003, and concentration of Cl minus ion is 0.003. In this case, the concentration of acid was equal to the concentration of H plus ion. But in all the cases, it will not be same. For example, I have sulfuric acid. Upon complete dissociation, how it will get dissociated? How sulfuric acid will get dissociated? How sulfuric acid, H2SO4, will get dissociated? It will get dissociated into 2 times of H plus and SO4 2 minus, right? So if I take 100 molecule of sulfuric acid, upon complete dissociation, how many H plus ions I'll be having? How many H plus ions I'll be having? One sulfuric acid molecule itself will give 2 H plus ions. Now I have taken 100 molecules of sulfuric acid. So how many H plus ions I'll be having? Very good. It is 200. Yes, in the children, it is 200. And sulfate ion will be just 100. Any doubt? Can I any doubt? So, if the concentration of sulfuric acid is 0.003, upon complete dissociation, could you please tell me the concentration of H plus ion? Concentration of H plus ion. If the concentration of sulfuric acid is 0.003, then what will be the concentration of H plus ion? What will be the concentration of H plus ion? Yes. So 2 times of 0.003, which is 0.006. Okay. So for both the cases, please calculate pH. So here they've given you the concentration of acid. From that concentration, you have to calculate H plus ion. And from that H plus ion's concentration, you have to calculate pH. So for first case, could you please calculate the pH? Here the value is very small. Please have it as 10 power minus something so that it will be easy for you. So how the 0.003 can be written? 3 into 10 power minus 3. Calculate the pH for the first case. That is for HCl. Yes, Muthulakshmi's answer is 2.523. That's it. So the exact answer is 2.52. Perfect. Superb, Kana. Now, guys, can you please do it for sulfuric acid then? You have the concentration of H plus ion, which is 0.006. So could you please calculate the pH for sulfuric acid? H plus ion concentration is 0.006. Muthulakshmi's answer is 2.223. Brilliant. That's it. Any doubt? Senthamil children? Mushkan?
Ma'am, this one, how come, ma'am? I am have more confused.
Okay. Which problem you want me to calculate, Kana? I'll do it now.
Last one, ma'am.
Last one in the sense you want me to do sulfuric acid?
Yes, ma'am.
Okay, fine. No problem. We'll do it. Kana, listen here. So the hypothetical question is, I have sulfuric acid whose concentration is 0.003 molarity. And they're asking us to calculate the pH of the solution. Okay, and what is the formula to calculate pH? pH is equal to minus log of H plus ion. So to calculate pH, we have to know the H plus ion concentration, right? Here, this is not the concentration of H plus ion. It is the concentration of this acid. So first of all, we have to know how this acid will get dissociated. As far as sulfuric acid, that is H2SO4 is concerned, this got two H plus ions, right? Actually, the structure of sulfuric acid is S double bond O, double bond O, single bond OH, and single bond OH. In an acid, if the hydrogen is directly connected to oxygen, then that is considered to be the replaceable H plus ions. So these two hydrogens are directly connected to oxygen. So these oxygen, this hydrogen will break the chemical bond with oxygen and will get dissociated into 2 times of H plus. And what is the remaining part? Sulfur, 4 oxygens, and we'll be having two negative charges because upon heterolytic cleavage, the electron in the chemical bond will get transferred to this oxygen, and similarly the electron from this chemical bond will get transferred to this oxygen. So this oxygen will have one negative charge, this oxygen will have one negative charge. So it is S44 2 minus. So this is how sulfuric acid will get dissociated. So H2SO4 will get dissociated into 2 times of H plus and SO4 2 minus. Are you clear till now,
Yes,
Mushkan?
ma'am. Yes, ma'am.
Fine. For example, I have only one molecule of sulfuric acid. One molecule of sulfuric acid, upon dissociation, we got 2 H plus and 1 SO4 2 minus, right? So I have 2 H plus and 1 SO4 2 minus. Similarly, if I have 10 sulfuric acid molecule, then how many H plus ions will be getting? One sulfuric acid gave us 2 H plus ion. So 10 sulfuric acid molecule will give how many H plus ions? Come again, Kana? I couldn't hear you.
20, ma'am.
Very good, it is 20. It's 20. Half 20, one molecule gave us 2 H plus ion. 2 molecule will give 4 H plus ion. So 10 molecule will give 20 H plus ion. So 2 into 10. How many SO4 2 minus ion, Mushkin?
Ma'am.
How many SO4 2 minus ions will be getting? Sorry? How many SO4 2 minus ion we will get?
2, ma'am.
One sulfuric acid molecule gave 1 SO4 2 minus. So 10 sulfuric acid molecule will give?
10, ma'am.
Very good. 10 SO4 2 minus. That's it. Similarly, if you have 100 sulfuric acid molecule, how many H plus ion we will get and how many SO4 2 minus ion we will get?
One second, ma'am.
Take your time.
200.
Very good, brilliant. That's it, 200. 2 into 100. So this 2 and into number of molecules. That's it. Okay, and how many SO4 2 minus ion?
20.
I'm dissolving 100 sulfuric acid molecule. So how many SO4 2 minus ion?
200.
One sulfuric acid will give one SO4 2 minus ion. So 100 sulfuric acid molecule will give
100, ma'am.
100 SO4 2 minus ion. That's it. So basically, for 1000 molecule, what is the trend here? I'm just multiplying this number with this number, right, Mushkan?
Yes, ma'am.
And for SO4 2 minus, I'm just multiplying this number with this number, right?
Yes, ma'am.
So here, uh, I've given you the data in terms of molecules. Now we'll talk about concentration. It is similar to molecule, no problem there. If I have 0.1 molar sulfuric acid, then how many H plus ion we will get? 2 into this number, 0.1. Right? How many SO4 2 minus ion we will get? 1 into 0.1. Right, Mushkan?
Yes, ma'am.
Now my question is, sulfuric acid's concentration is 0.003. Now can you please calculate the concentration of H plus ion? Take your time.
Ma'am, once more 10.
See, if the concentration of sulfuric acid is 0.1 molarity, then what will be the concentration of H plus ion?
2 into 0.2.
Yes, how we got 2 into 0.1? 2 is the number of moles of H plus ion, right? 2
Okay,
into
ma'am.
0.1 is the concentration of this acid, right, Kana?
Yes,
Similarly,
ma'am.
what I'm asking is the concentration of sulfuric acid is 0.003. Then what will be the
2
concentration?
into
Hmm,
003.
0.003. That's it. That is what I've written here.
Okay, ma'am.
Okay, now we got the concentration of H plus ion. Kana, 2 into 0.003 is nothing but 0.006, right?
Yes, ma'am. 2
So
3
this is the H plus ion concentration, which is 0.006. Now we have to calculate pH. What is the formula? pH is equal to minus log of 0.006. See, we don't know the value of 0.006, that is log 0.006, because we have memorized only four values for log. We know for log
Yes,
2,
ma'am.
log 3, log 5 and log 7. It is a little different, right? So
Yes.
what I'm going to do is I'm going to write it in terms of 10 power. How I can do that is I'm just bringing this decimal point to the rightmost corner. I'm just bringing here. So it is 6 into, I'm just bringing the decimal point to the right. I'm moving 3 decimals, right? So 3 digits, 1, 2, 3. So it is 10 power minus 3. Okay, Kana.
Okay.
So if you bring the decimal point to the right, the power in 10 will get reduced. I'm just bringing the decimal point 3 decimals. So I have to reduce 3 numbers in the power. So it is 10 power minus 3. Now Please have this minus as such. Now we know the formula, right? Log A into B. That can be written as log A plus log B. Am I right, Kanna?
Yes, ma'am.
Now I'm going to write this log 6 as such. Kanna, log 10 power minus 3. This is similar to log A power B, right? What was the
Yes.
formula for log A power B?
Log A plus log B.
If log A into B, your formula is right. Log A plus log B. But here it is log A power B.
B log B.
Yes, it is B log A. See, the formula is here. Very good. Now, so here instead of B, we have minus 3, right? So minus 3 log 10. And now what is the value of log 10?
1, ma'am.
Very good. So log 6 minus 3. That's it. Plus into minus is minus 3. Log 10 is 1. That's it. I'm going to multiply this negative sign. So it is minus log 6 minus into minus plus 3. That's it. So what is pH? 3 minus log 6. Right, Mushkan?
Yes, ma'am.
Now we have to know the value of log 6. That is very easy. We can calculate that. See, I've given you the problem, calculating log 45. It is similar to that. How, how we can write the 6? 6 can be written as 2 into 3. Right, Kana? 2 into 3 is 6.
Yes, ma'am.
So how this log A into B can be written as? This is log A into B. So log A into B can be written as log A.
2 plus log B.
Very good. So this is log 2 plus log 3. That's it. Now you know the value of log 2. Refer your notebook and tell me what is the value of log 2.
0.3010.
Brilliant. 0.3010 plus what is the value of log 3?
0.4771.
If you add these two values, you'll get the value of log 6. Substitute here and subtract it from 3. That will be your answer. Can you do it now? Can you please add both the values? Cannot take your time. Just add both the values and tell me. That is enough.
0.7781, ma'am.
That's it, 0.7781. Now we have to substitute it here. 3 minus 0.7781. Now subtract and tell me, Kana.
0.4781.
3 minus 0.7781. 3 minus 0.7781. From 3, you have to subtract 0.7781. If it is difficult, then please subtract just 0.7. If it is difficult, then just subtract 0.7. That is enough. 3 minus 0.7. 3 minus 0.7.
4, ma'am.
Uh-huh. From 3, you're subtracting something, right? So this is
Yes.
3, you have to subtract 0.7. See, decimal is, we have so many value, so many digits, right? Don't take all those steps. Just take 0.7. From 0, we cannot subtract 7, right? So we have to borrow. So from 10, we can subtract 7. So 10 minus 7 is 3. Point, 2 minus 0 is 2, and we have to write the sign of the bigger number, so it is plus. So answer is 2.3. That's it. So
Okay,
this is
ma'am.
the okay, this is what Mutalakshmi told. See, she told it is 2.22. Almost we got the answer right. That's it. This is how we
Yes,
have to
ma'am. I
calculate.
understood, ma'am.
Okay, now it is not confusing, right?
Yes, ma'am.
That's it. Very good. Thank you for asking. Thank you for telling me that you don't understand. That is why I got this opportunity to explain, Kana.
Thank you, ma'am.
Fine. Kana, any more doubt? Mutalakshmi, Sendamil Shelvan. Okay, fine. So if you guys have no doubt, then shall we wind up the session?
Okay, ma'am.
Fine. Okay, Kana. So in next class, we'll be discussing few more problem related to pH. Okay. Fine, Kana. Okay. Bye, guys. Bye bye. Good night.
Thank you, ma'am.
Bye, Kana.